Hi, I'm Josh from SpectraCal, the creators of Calman display calibration software. In this video series, I'll be showing you the Netflix display calibration best practices. The system we'll be showing you is one example of a typical studio setup. We realize there are many different configurations and this may or may not match your particular environment. The two workflows we'll be showing you have been carefully designed in collaboration with Netflix to accommodate all system configurations. If you have questions about your specific environment, you can email support@spectracal.com or call our tech support phone line shown here. You can also view different configuration videos on our YouTube channel. Since we'll be doing a deep dive on several different topics, here's a quick overview of what we'll be covering in this series. Why calibrate? We get asked this question a lot. If there were only one display in the entire world, you wouldn't need display calibration. Calibration ensures a uniform viewing experience across all displays. Most facilities have 3 or more differing display technologies for different purposes. A large monitor for the client, the main reference monitor for critical viewing, and 1 or 2 computer monitors for the user interface. This is just one example. These displays all produce different colors and at different intensities in native form. And with the emergence of new display technologies like OLED, wide gamut, GB-R LED, red, green, blue LED, quantum dot, laser, and so on, comes even greater visual differences. We expect this to continue to increase for the foreseeable future due to display manufacturers looking for ways to advance pixel quality and performance. This makes display calibration even that much more important. The follow-on question people typically ask is, so how do you get a uniform viewing experience when you have an OLED, plasma, and LED side by side? The answer is you calibrate all displays to the appropriate standard for the intended use. The Netflix Topology 1 and 2 recommends HD 709 for HD video monitors and sRGB for computer monitors in Topology 2. Netflix Display Calibration Best Practices Initiative. Netflix states, a wide variety of display types and viewing environments can lead to inconsistent quality results. And to ensure consistent quality, a set of guidelines must be put into practice which adheres to a common standard. Netflix believes calibrated displays ensure that all seen objects are properly presented as originally intended, and without calibration, compression artifacts may be invisible due to miscalibration. The Netflix initiative requires all NPVs, Netflix preferred vendors, involved in media processing or quality control to provide a quarterly report of Netflix display calibration for designated systems. This is in the best interest of all partners to ensure that their fleet of displays is operating within standardized tolerances to achieve top quality. Therefore, all displays used in quality analysis of Netflix licensed or original content will require periodic calibration and a corresponding report for each. In an effort to standardize methodologies and reports, Netflix has recommended SpectraCal as the go-to vendor, and Calman created workflows and reports as the go-to software solution. Topology 1 and 2 Overview. Topology 1. This applies to SDI broadcast monitors and reference HDMI or DVI connected displays from a reference output device such as AJA or Blackmagic design. Displays in this topology typically expose full controls for brightness, contrast, and color and are not managed through a computer's graphics card output. Topology 2. This applies to computer monitors, either integrated into a computer workstation or connected to a computer's graphics card. For example, a MacBook Pro, iMac, Mac Pro, Windows PC, etc. The workstation's operating system and/or applications, along with the graphics card 1D LUT, manages the color output of the display. Displays in this topology typically do not expose controls for color or gamma, but are managed by the attached computer and graphics card. This topology requires the download and installation of the Calman Client 3 software, which generates the patterns and manages the ICC profiles. This client software will run on Windows or Mac. Recommended tools for the job. The tools for the job consist of Calman software, a meter, and a test signal pattern generator. The pattern generator sends a color patch to the display, the meter measures the color, and Calman software analyzes and compares the measured results to the standard using charts and graphs in real time. The Netflix video monitor and computer monitor workflow and report, Topology 1 and 2 respectively, leverage technology in SpectraCal's flagship product called Calman Ultimate Display Calibration Software. This software communicates with the hardware to provide a synchronized process. It also holds all of the standards required by Netflix best practices, the Topology 1 and 2 workflows and reports. Included with Calman Ultimate software is 10 client licenses for calibrating Topology 2 systems. One client is required for each Topology 2 system regardless of the number of displays connected to the graphics card or computer monitor. Netflix's recommended measurement device is the SpectraCal C6 colorimeter. This is a versatile device, highly accurate, excellent at black levels, comes with a NIST Certificate of Performance, and supports most all display technologies at NPV's facility. It's the minimum recommended device by Netflix. There is also 50+ other measurement devices that Calman supports, including some of these popular colorimeters and spectroradiometer devices. For example, the client instruments K10A and K80, the Colorimetry Research CR100 and CR250 RH spectroradiometer, the Jedi SpecBoss 1211 Spectro, all the Konica Minolta devices, Photo Research, and many more. If you have questions about the hardware that you may already have or you're interested in purchasing with your calibration kit, feel free to contact us and we can help recommend the best tool for your display systems. For pattern generation, Netflix suggests the test pattern generator should be under the control of Calman, such as the Virtual Forge Pattern Generator software. The Virtual Forge Pattern Generator software turns your Mac or Windows machine into an automated test pattern generator. It's an innovative and convenient alternative to hardware-based pattern generators. It uses either a Thunderbolt port or PCIe slot on your computer, along with popular AJA video or Blackmagic Design output devices. This is what provides the needed reference test patterns to the monitor. An added benefit of using this configuration is that it pipes all the patterns through the existing video chain. The Virtual Forge includes all the traditional patterns, such as brightness, contrast, sharpness, SMPTE bars, as well as any of the RGB triplet combination for saturation sweeps, luminance ramps, grayscale measurements, gamma, color, 1D, and 3D LUTs. Literally millions and millions of pattern options. This complete kit will enable you to measure, calibrate, maintain, and report on reference monitors, client viewing monitors, computer workstations, and any viewing suites to match the same standards and ensure a uniform viewing experience. Now that you have all of the tools purchased for the Netflix Topology 1 and 2 process, you're going to need to download all of the software applications to get your system up and running. The first thing you want to do is go to a browser and go to spectracal.com/Netflix. Once you're on this page, you'll want to scroll down a little bit until you get to the form here for gaining access to all the applications. You'll want to put in your company information, first name, last name, email address, and once you click submit, it will expose the Calman software as well as the workflows. So the first thing you want to do is download Calman, and with that running in the background, I'll go ahead and start downloading the Netflix workflows and reports. Download this here. Okay, so that's downloading as well. If you're going to be running Virtual Forge Pattern Generator application on a Windows operating system or a Mac OS X, you can download either of those options here. And since I'm running the Virtual Forge on this Windows machine locally, I'm going to go ahead and download the Windows version. Now for Client 3, this is for calibrating the Topology 2 systems, and the Client 3 manages the color patch changes on that display as well as the ICC profile and the 1D LUT. So basically you just download the one that's appropriate for the computer you're calibrating. In this instance, I'm going to do the Windows version, so I'll go ahead and download Client 3 for Windows. So now I've got all the software either downloaded or in process of being downloaded. First thing I'm going to do is I'm going to go ahead and start installing Calman software. Now that Calman is finished installing, I'm going to go ahead and open up Calman. And with the Calman software open, I'll want to go find the email that was sent to me from our operations department. This will have the license key for activating the software. And with the license key window open, you'll want to right click and paste the license key, click Add License. If you got the whole license key right, it will activate the software and it'll bring you to this prompt where it says, added successfully, ready to go. The next thing we'll want to do is we'll want to import the Netflix workflows and reports. So to do that, we're going to want to go ahead and close down Calman, open up a file explorer, navigate to the C drive, then users, your file folder, then go to your documents, then SpectraCal, then Calman 5 for Business, then Workflows. With that open, now you want to navigate to where the workflows are recently downloaded. Select the Topology 1 and Topology 2 workflows, which are video monitor and computer monitor. Copy those into the Calman workflow directory. Back up one level into the Calman for Business, and then go into Reports folder. Select both workflow reports. Copy and paste those in. And what this will do is it will enable these to be accessed from in the application in the future. You won't ever have to do this process again. It's a one-time thing. This just sets it up so that way in the future, if you want to go right into a Netflix workflow, you can configure the preferences so that it just does that each time Calman opens, and you don't ever have to access this through this process. And I'm going to go ahead and open up Calman just to make sure I can see the workflows and the reports. And with Calman open, I can go into the menu system here and see, yep, sure enough, I've got Netflix computer monitor and Netflix video monitor. I'm going to select this. This is the Topology 1, and I'm going to go ahead and start a new session. The next part of configuring my system to calibrate a Topology 1 system or a Topology 2 system would be installing the Virtual Forge pattern generator. And to do that, I'm going to go ahead and find the Virtual Forge download. Accept the terms, go ahead and install the software. I'm going to go ahead and say restart later because we're going to go through a few more parts of this process. And I'm going to go ahead and get a copy of the license that was emailed to me for Virtual Forge. With the Virtual Forge application installed, I'm going to go ahead and ensure that the license has properly been activated. So I'll go ahead and right-click, go to the About screen. Since I previously installed the license key, you'll see that it's already in this field. If it hadn't been licensed yet and the first time you were setting it up, you would send this machine ID into our operations manager. They would generate a key based on this machine ID, and then you would copy and paste that string into here and click Add License Key. It would then activate the software so it would work with Calman. We've already done that, so we'll go ahead and just close this up and jump right into Calman, make sure we can connect to Virtual Forge. With Calman open, I'll go ahead and select the Source tab dropdown, select Find Source, SpectraCal, Virtual Forge, and sometimes you'll see the IP address of the device that has the Virtual Forge running populate automatically in this field. If that happens, great, just select this and click Connect. If that doesn't happen, you can either use the search button or you can just manually type in the IP address if you know the machine that's running Virtual Forge. I'm going to go ahead and select that and click Connect. And I know that we've properly connected to the Virtual Forge because I've got a green light here on the left, and all of my setting options are exposed to me now. So I can change the window size, I can change the APL, average picture level of the background and the pattern, and I can also select all the different specialty patterns. When you connect to it, it'll also send out the grayscale steps immediately once it's connected, so you'll have visual verification of the display you're connected to. So that's for a Topology 1 system using the Virtual Forge as a pattern generator. For a Topology 2 system, you would want to select and install the Client 3 application. To do that, I'm going to go ahead and go back to my downloads, install the Client 3 software. And with Calman Client 3 software installed, I'll want to ensure that everything is functioning properly. So I'm going to go ahead and disconnect from Virtual Forge. I'm going to open up the Netflix computer monitor workflow. Now I'm going to verify that the Client 3 software is properly installed and ensure that it can properly connect to Calman. So I'm going to go ahead and find it down here in the tray icon, right-click. I'm going to go to Preferences, and I can see that sure enough, the application is running as intended, and it's seeing the monitors that it's connected to. I'm going to go ahead and exit out, and I'm going to make sure that Calman can connect to it. So I'll click Find Source, SpectraCal is a manufacturer. I'm going to select the Calman Client 3 pattern generator, select the machine that's running the client, and click Connect. Alright, so now I know that I'm properly connected to the Client 3, and this system is fully configured to measure and calibrate a Topology 1 or 2 system. Topology 1. Watch the complete series or select a chapter to jump ahead. Now that we have the Netflix video monitor calibration workflow open, we're going to go ahead and show you the welcome page. On this page, you can enter your company information by clicking this button, filling in these boxes, and then hit Save Edits. You can enter your particular information if you're an engineer or you're a calibrator, a technician. You click the Edit Calibrator information, put in your name, phone number, email, any notes about yourself, and then hit Save. You can rename the session for this particular calibration. We recommend having something like maybe the room that you're going to be in, or the workstation name. Maybe it's Edit Bay Suite 1. You could put that here with the date. And then we have the calibration standards. Now, out of the box, because we've collaborated with Netflix on this, we've already defined the color space, gamma, grayscale steps based on what they would like you to follow on the Netflix display calibration best practices document. However, if for some reason you need to change these standards, let's say you're in another region of the world, maybe you're in Japan and you need to do, instead of D65 white point, you need to do the D93, or you have a monitor that has 21 points of adjustment for grayscale, you could simply select those items here and then move forward. And here's the display information section. This is where you enter the workstation that you're going to be calibrating. So the first thing you do is click New Display System, put in the display system name. In our case, we're in Lab 2. Maybe in your particular system, you would say something like Edit Bay 2, Edit Bay 1, Design Room. Description of the system, if you have one, I'm just going to leave it blank. There's no need for that for our use case. Display manufacturer, I'm going to be calibrating a Panasonic, and it is a LED LCD. I'm not going to put the model number, so we'll go ahead and enter the serial number that you could put that there as well. Once you've done that, you click the Create. You'll notice it'll update this information. It will create a new session start date, which is today's date. And then here's where you connect to the calibration equipment. These are the devices that you use to calibrate the monitor that you're going to be generating a report for. So the first thing you do is you want to connect to the meter. And if you don't know how to do that, you can either watch this video or you can click here and watch another video that shows you how to do it. So you click Connect to Meter. This brings up a Find Meter pop-up box. And if you're connecting to, like we are, a C6 or a C6 HDR, you can leave this box checked. This is all meters except those listed below, and then just simply hit search. If you're using a higher end instrument, let's say like a colorimetry research, a Klein Instruments, a Konica Minolta, photo research, find the one that you would be connecting to here, select that, and uncheck this one. Select the COM port that it's attached to, and then hit search. But again, for our instance, we're using a C6, so we just leave this checked and we hit search. While it's searching for the meter, I just want to mention that you can also access the meter, you can connect to it, you can adjust the settings, you can do all of those things as you can from this main page. You can do that right here from this drop down. It's a handy little feature because if you're later in the calibration process and you want to switch the exposure time, the samples, you want to change the meter profiles. Maybe you've done a specific profile, for example, like the Sony OLED, and you want to make a compensation for that. So you could adjust that here. Change the display type. If you're calibrating one display and you go to start another calibration to another display type, you can select that here. So this is available in the welcome screen and the drop-down tab. Since the display we're going to be calibrating is an LED LCD white, it's important to select the right meter mode profile for the display type that we're calibrating. So in this case, I'll select LCD LED white. Now, we're going to be doing a video on how to select the right meter mode for your display because there are so many. We're also building a list that's going to go onto the Netflix server. So that way, if you have a particular display that you don't know what the meter mode is, send that information into Netflix and or SpectraCal, and we can find out what display type it is and then provide that to yourself and Netflix, and then they'll update the library, and that way there's always a constant updated report or a depository of that kind of information. So now that I've selected this, I can move forward to the next step, which is connecting to the pattern source. Now the pattern source is what pushes the patterns to the display, so that way when we're measuring gamma, for example, it's going to measure 100% white, 0 reference 16 video level black, and then it's going to go up at 5, 10, whatever the percentage increments all the way up to back up to 100. And in order to expedite this whole process, you need to have Calman talking to the generator in order to push those patterns out when they need to be pushed out. So it's in perfect synchronization of putting a pattern out, measuring that pattern, filling up the data in the chart and graphs, switching to the next pattern, and then doing it again, and not having a mismatch of reading and data field. So I'm going to go ahead and click Connect to Pattern Generator, and the Netflix program recommends either using our Virtual Forge pattern generator because it has all the traditional patterns that you're used to, like the contrast and brightness plooge patterns, empty bars, grayscale steps, ramps, gradients, all sorts of patterns, plus it also generates all of the RGB triplet patterns for doing things like any color patch for the color checker, measuring the Netflix logo, the Netflix red color, and then doing anything for 1D and 3D LUTs. So it can generate essentially thousands and thousands of color combinations. So to connect to the Virtual Forge, you can see that I've already got it set up here. I've got manufacturer SpectraCal. The model is a Virtual Forge. It's running on the same machine that I'm running this calibration on. If you're running the Virtual Forge or the pattern generator on a computer that was on the network, you would just find it in this drop-down, or you could type in the IP address and then click Connect. In order to do that, you would need to make sure that the machine that was running the Virtual Forge was not only connected to the network, but also had the appropriate AJA or Blackmagic hardware, along with Virtual Forge running on that machine before you try to connect to it. If those things weren't already set up, when you try to connect, it wouldn't find it because it wouldn't be there. So just make sure you've got Virtual Forge running on that target computer or the machine that you're running the calibration from, like I am here. Go ahead and connect to it and you're good to go. Now this third option, you rarely ever connect to it. It's basically the display. Because Calman can talk to the meter to take measurements, the pattern generator to change patches, and because we partnered with some display manufacturers, we can actually make the changes for you. So you don't have to go in to the RGB cuts and gains and start fiddling around with balancing them to reduce the error. You can simply connect to the display, and when you get to the process later in the workflow, you click this button that says AutoCal. It just goes and runs and does it for you, and it typically takes anywhere from 2 to 5 minutes depending upon the controls that are exposed to us. But there are very few displays that we can actually talk to. Just it's a slow process for us to be adding these and partnering with all the display manufacturers that are out there. If you're curious what displays are available that have this AutoCal capability with Calman, you can simply click this Connect to Display, which will bring up the dialog box, and you can see all the manufacturers we currently work with. And once you've selected a manufacturer, let's say Panasonic for example, you can see all the different models that we have available and how to connect to them. You can also, again, access the same information and control from this tab up here at the top. If you're curious about how this all works, you can click this link here, which goes to a video and shows the entire process. That's the same for Virtual Forge as well. Okay, so we've got our meter connected, we've got our pattern generator connected, we've got the right mode selected for the display that we're going to be measuring and calibrating, and I can see that that information is all set up here. If I had any information that I wanted to document about the system, maybe something I know about the display, maybe it's getting old and it's going to be phased out, maybe this is the display you're using for the time being, you could put those notes in here and they would carry through out the workflow, and then it would get dumped into that report, so that way when the Netflix NPV members are reviewing the report, they can see, oh, well, the reason this display wasn't performing as good as it should is because it's older and it's aging and it's going to be replaced. So I think we're all set up on this page. We'll go ahead and move on to the next screen, and we can do that by clicking the next button here. On the pre-calibration page, you want to gather data on the display's as-found performance. To start the process, you want to click the Read Series button down here in the lower right corner. And what that's going to do is it's going to measure 100% white point, your reference black, or 16 for video levels, and it's going to go and measure all the points in between at 11 steps of gray at 10% increments. It will also measure the primary and secondary colors, and then plot out all the error for those particular color points. As you can see, it's generating 3 lines of color in this RGB balance chart. On a perfectly balanced or calibrated display, you would see all 3 red, green, and blue lines go flat across this line. And what that would mean is that the very specific amount of red, green, and blue, which makes up white, would be balanced, and that you would have the perfect grayscale across the entire dynamic range of the display. And what this chart shows here on the right is the rate at which the display goes up from black to white. And then we have the CIE chart, where you can see the primary colors, red, green, and blue, and the secondary colors. As of right now, you can see that there's a significant shift towards blue on the white point, which is right here in the center. This measured round dot is what the meter sees as the color. This square is the target area, so you can see we're outside the target. You can also see that in the RGB balance chart, where we've got blue is much higher than it should be. So you can imagine this display is looking a little cool, a little more blue, and we're deficient in red. And then if you look at the color comparator here and here, you can see that in this visual example. The bottom set of boxes are the RGB triplet value of what the target color should look like, and above it is what the meter sees as the color. So if you look at 70%, you can see that, well, this is a pretty gray looking color, and the meter sees a much bluer, much cooler looking gray. So we need to balance this out. There's some helpful information on the top left. We have a grayscale DE2000 error, and an error of 9 is really high. We want to have this be hopefully under 2 or 1 if possible. Our max is 14. That's really high, so there's some very visible error. We did 11 points of grayscale. This is adjustable based on the display system that you're measuring and calibrating. We have a very cool color temperature, closer to 10,000. It really should be 6503 or the D65 white point. Gamma needs some adjustment as well. And also some things to note for black level and white level. 0.0001 level for measured black. If you see something like that, it's probably wrong, and you probably have a panel where the backlight shuts off, or there's some sort of control over the panel. And when you get a value like this, it's going to give you this insane on-off contrast ratio number. This isn't a true on-off contrast ratio number. I'm sure the manufacturer would like you to think that is the right number, but in order to get a proper on-off contrast ratio number, what you need to do is you need to switch your pattern generator to output constant APL patterns. And we'll show you how to do that in a little bit. For white level, you can see 240 nits is really, really bright. This display in this environment should be at 100 nits. That's what Netflix recommends in their display best practices document. So we'll go ahead and adjust that in a little bit, and we can get that fixed up. But this is where the display is sitting right now. For color space, similar error levels, we got 6.7 and almost 14. And you can see that here if you hover over any of the values. Ideally, we'd want to have all of these under this green line. All right, so that's the pre-calibration page. We'll go ahead and click next to the next page. If you recall from the previous page, the luminance of the peak output level of the display was about 240. On this page, we simply want to measure the luminance level with a white pattern on the screen, and we want to either turn down or turn up the backlight, if your display has one, until you're at 100 nits. Netflix knows that not all environments are the same, and if you have windows in the room where there's additional ambient light, you may want to actually target something higher than 100 nits, maybe like 120, or in some cases go as low as 80. So there's some wiggle room here, but the goal is to have everything at 100 nits. And so what we're going to do is take a single reading to see where the display is at, and yep, we can validate it's similar to what it was when we did the pre-calibration gathering of data. So we're at 238, 48, and we want to turn the backlight down until this reads about 100. So I'll go ahead and put the meter into what's called continuous read mode, and what that's going to do is take continuous readings over and over and over again. As I bring down the backlight, I can see the measured value change in real time. That'll help me dial this display into where it needs to be. So I've got the remote in hand. I'm going to go ahead and go into the menu system, which you'll see a dip in the value because now it's measuring the menu system. I'm going to find the control for the backlight. In this case, it's actually called backlight. So I'm going to select this. It's going to bring up the control, and then I'm going to start turning it down. And as I turn it down, I'm going to see this value come down. It's at 150, 140, 130, 120. And usually we recommend having it slightly above 100 for this stage of the process, maybe like 110 or 105, somewhere around there. And the reason for that is when you calibrate a display, you end up taking either red, green, or blue. If it's an LCD, you typically take blue out of the top end to balance out red, green, blue at the top. Well, what that does is it reduces the overall peak output of the display. So if you give yourself a little bit of headroom, you'll find later in this process that you may have brought it down below, well below 100. So if you start a little bit over 100, you can always tweak it a little bit as needed once you get to that next phase. So I think this is good enough. I'm going to X out of the menu system. I'm going to take a stop reading, and we'll go to the next page. All right, on the dynamic range page, there's actually quite a few steps that you're supposed to do here. Some client viewing monitors, and we don't see it, we see it less and less in reference monitors or broadcast monitors, but there's a bunch of settings specifically in client viewing monitors that you want to turn off. And the first thing I'm going to do before I get into setting brightness and contrast is I'm going to go into the menu system on the display and find any sort of high motion, automatic dynamic range adjustment, backlight control, any sort of ambient light sensor modification, I'm going to turn all that stuff off, or at least make sure that it's off in the mode that I'm in. So the first thing I'm going to do is I'm going to use the remote control for the panel, go into the menu system, and I'm just going to run through all the settings to make sure there's nothing. Yeah, see vivid color, that you need to be off. Adaptive backlight control, it's on mid. We need that to be off. That's off, 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 off. Now that we've made sure all of the processing or extra enhancements that the manufacturers put into the panel for consumers has been turned off, I'm going to go ahead and set the brightness and contrast of the display. To set the brightness, I'm going to go up here and push the brightness button. That's going to enable a brightness pattern on my display. Then I'm going to find the brightness control in the menu system. I'm going to hit menu. On this display they actually call it brightness, so I'm going to select that. And I usually turn it up well beyond where it should be, just so I can see everything, and then start turning it back down. Since we're looking at a pattern that is for 10-bit, which for 10-bit, 64 is our 16 video level black, and 16 would be an 8-bit, so 16 or 64. So what I want to do is I want to turn down the brightness until 64 blends into the background. Then I know that my reference black is set properly. So I'm going to go ahead and start turning it down until it just finally disappears into the background. And you want to stand in the middle of the display and keep your eyes as close to the center as possible. Don't look at the display at an angle. This is the best way to set your brightness. And from this position it looks like +1 is where we need to be. So I'm going to go ahead and exit out of the brightness control, and we're going to go ahead and set contrast. I'm going to go ahead and push the contrast pattern up on the display. And looking at the pattern, I can see that 924, 928, 932, 936, maybe you'll see a little bit of 940 are visible, and the rest are completely gone. They're all blended into the background. Right away, I think something is not right here. And what I'm going to do is I'm going to go ahead and use this tool to do a read series and see what happens with the red, green, and blue channels as it goes up over 936, 940. And when I do that, it's just going to take a few snapshots at the top end of the dynamic range. We're seeing at 90% all the way up through 109. And looking at this chart, I can see I've got my red channel, my green channel, my blue channel. They're all pretty far apart. It's not the end of the world that they're far apart. This just means it needs calibration. The part that I'm concerned about is that I run out of red down here well below where I need to be. So just shy of where I need to be, I'm losing red, and I'm losing green, and it's basically this is called clipping, and we need to fix that. So I can see it here in the chart, and I can see it here in the pattern. So what I'm going to do is I'm going to go into the menu control on the display. I'm going to find the contrast adjustment, and as you can see in this particular mode it was all the way up to 100, so that's too high. We need to bring it down so we can start seeing this detail. And as I bring it down, I can see additional boxes showing up. I'm now at 968, 980, 988, 992, 1000. So now I can see almost all the boxes up to 1012. Since we're talking about video levels for Topology 1 system, we want to set in 8-bit land at 16 to 235, with 235 being our white point, and you always want to leave room for information above 235. With this pattern, it's showing 10-bit, and 235 equals 940. So I can see all the way up to 940, plus I can see a bunch of detail above it, and I feel like my contrast is still cranked up pretty high, so I probably haven't lost too much dynamic range. I would say this is a good place to set the display at, but let's just go ahead and run another read series to see how my red, green, and blue channels are looking. I'm going to go ahead and click the read series. So by eye, I've said that it's good to go. Let's just do a test with what the meter sees, and sure enough, I now see all of my lines are running parallel to each other, and none of them are clipping anywhere in this particular snapshot of the dynamic range. So I'm happy with brightness, I'm happy with contrast. I did lose a little peak luminance, you can see, from turning down my contrast, but we can go ahead and fix that when we get to a later step when we recheck the luminance level and adjust the backlight. So for now, I'm happy with these results. I'm going to go ahead and click the next button. On the Grayscale 2-point page, the first thing you want to do is click the Read Series button. This is going to measure white point towards the top end and a darker gray point towards the low end. And it's going to show us how balanced red, green, and blue are at both ends. Now, I like to think of these two as the ends of a teeter-totter. You want to balance both sides in order to flatten out the entire teeter-totter. So you always want to start at the top end, and so I'm going to click the 100 pattern patch. It's going to push the right pattern on the display, and it's going to activate this set of RGB values, and it's going to show the error here in this DE2000 chart. Now I can see there's a lot of error in this chart, and that's because I've got way more blue than I should. Ideally, red, green, and blue would be balanced at 100. Now that I've got the 100 pattern displaying on the monitor, I'm going to click this continuous read button, and it's just going to keep taking readings over and over again of that 100 pattern. And while it's doing that, I'm going to open up the menu system on the display, and my readings will be thrown off while it's doing this because it's measuring the menu, so pay no attention to that. I'm going to go into the Pro settings, and I'm going to go into the white balance detail adjustment. And here you can see I have WB high and WB low. Since I'm measuring 100, I'm going to want to measure and adjust the high values. And since I've got too much blue, that's the first thing I'm going to start adjusting. I'm going to start taking out anything that's over the 100% target level. It's always easier to take away color than it is to try and add or drive more. Oftentimes the panel is at its max, so if you try and push a color up, you may run out of room, or you may not have any room to go. So it's better to take away. I'm going to start with blue, and I'm going to start just bringing it down until I get blue down to 100. And I won't pay too much attention about the other colors, because right now the goal is to get them all at 100, and since they interact with one another, I'm just going to have to go back and forth between the different adjustment colors. So I'm pretty happy with where blue is at now. I'm going to go into my menu system, and now that green is the higher one, I'm going to select green, and I'm going to bring that down until it's at 100. And as you can see, when I bring green down and blue, you can see my errors coming down. So I've still got some work to do because I'm sitting at about 3 3/4 DE. I still want to get this below 1 if I can. So I'm happy with green. Let's go back to blue and take some more out of that. So far I haven't even touched red, but because I'm adjusting green and blue, red is coming up since I'm reducing. These are all interrelated. So I'm just going to keep taking blue out. I'm going to go back to green, take green out. And now you can see my DE is about 1, just a little bit over. I'm going to go back to blue, and I'll take just maybe one more click out of blue. Now you can see I'm almost perfect, 0.1 DE. That's incredible. So I'm going to go ahead and I'm going to stop the meter from taking measurements, and I'm going to turn my menu system off and do a read series. It's going to remeasure 100, and it's going to remeasure my 30. Wow, all I did was adjust my high red, green, and blue values, and look how it impacted the low end. That's because these two interact with one another. I really don't need to go any further. If I wanted, I could tweak the green a little bit to get it maybe 1 click further down, but I could be wasting time on this page since the next page shows me the entire grayscale balance across the entire dynamic range. So right now I've got my 2 points of adjustment at 100. I'm at 0.1 DE, which is perfect, well below the visible error, and then at 30 it's also below 1, so you don't need to do any more. My color temperature is really close to D65, it's 6480, so I'm going to go ahead and click the next button. On the previous step, we balanced the 2 points of red, green, and blue. On this step, we're going to measure the grayscale across the entire dynamic range. That includes our black reference level 16 all the way up to 100% white. The first thing you're going to do is just click the Read Series button. It's going to gather all the data. Now, if you remember on our pre-calibration step, there was quite a bit of error in blue. It was well above where we want it to be, and we were also deficient in red. Since then, we adjusted the 2 points of grayscale. We adjusted 1 point at 100 and 1 point at 30. When we remeasured our 30 and 100 after adjusting 100, we found that we were able to balance out the red, green, and blue pretty good at the bottom end. And you can see that here in our results so far. So all we've done is adjusted 2 points of grayscale, and already we're seeing that this display is pretty well balanced. Ideally, all 3 lines would be across the 0 line. And you can see here in our gamma even improved a little bit after doing our balance. Our DE2000 error shows us that almost everything is at about 1 of DE, and for our average, we've got 1.3, our max is 2.0, In the Netflix display best practices document, as it stands right now, they're saying that an average of under 3 is acceptable and a max of under 5 is acceptable. So this is already under the acceptability of what Netflix recommends. And I've got 11 points of grayscale adjustment set here on the monitor. One thing I'm going to show you about this display is that it actually has some other adjustment points. So when I go to the menu system, select picture, go to Pro Settings, white point detail, and now you can see all I've done here is adjusted red, green, and blue on the high end. When I go down here to more detail adjustment, you can see that I actually have the ability to select the input signal levels. 100, 90, 80, 70. I've got at every single 10% increment, I can adjust the red, green, and blue values. This would be considered, since I've got 10 through 100, this is a 10-point grayscale adjustment. So what I would do if I wanted to adjust individually each one of these points, I would select from this drop-down that this is a 10-point system, and then I would do a read series, and I would move along the red, green, and blue adjustment points, and I would adjust each individual red, green, and blue until all of them were perfect. So I could perfectly dial this in. For this video, I'm just going to show you the 2-point system, but if you really wanted to dial in your monitor, you could go in and tweak this further. What I will do, however, is adjust the gamma, and so I'm going to go ahead and go back to our 11-point, and I'm going to pull up the gamma control, go into Pro Settings, gamma detail. There's a global adjustment change where I can set it to a global change of 2.2, or I can go into more detailed adjustment and I can actually change the input level across each point. So that's exactly what I'm going to do. I'm going to go ahead and set this to measure 90. I'm going to go to input signal level. I'm going to go to 90. I'm going to select the gain control. I'm going to take a continuous measurement, and while it's measuring this, I'm looking at this gamma chart, and you can see how as I bring it up or down, it goes up or down discretely for that point. And I'm just going to adjust it until it sits underneath this yellow line. Once I've done that, I'm going to go ahead and hit stop. I'm going to measure 80. I'm going to select 80. Until it's there, I'm going to hit stop, select 70, go into my menu system, select 70, do a continuous read, hit stop, select 60, menu, put level, select 60, gain, continuous read, and as you can see here in the RGB balance chart, as I'm fixing the gamma, I'm also fixing the RGB balance, and these are all interrelated. When you balance red, green, and blue, all you're doing is you're fixing the chromaticity of the color. You're just making the red, green, and blue balance to that particular white point. But in order to also get it to correct for the luminance level, you need to adjust the gamma. So each particular point has a specific place based on the display's measured white and measured black, and that's because we're using the BT 1886 gamma formula. So looking at this, I need to keep going until I'm about, that looks good. I'm going to hit stop. Measure 50, go to the menu, select 50, gain, continuous reading, and right there looks pretty good. Hit stop, go to 40, menu, go to 40, gain, continuous reading. Looks good. Hit stop, go to 30 on the display, go to 30, gain, continuous reading. Looks like we're getting close to being done here. Continuous read. And you'll notice that as you start getting into the darker patches or patterns, the meter may take a little bit longer in between reads. Calman has been optimized along with the C6 HDR to automatically change the exposure time for the dark level readings. And what that does is it helps give a more stable reading of that gray level. As a panel puts out less light, it takes more light to saturate the sensors in the device. And that's why colorimeters are so good at measuring black levels, because they usually have larger sensors and there's fewer of them with the larger lens, whereas a spectroradiometer has a smaller opening, tons of sensors, but the light's being broken out across the visible light spectrum, and tiny little bit of light is hitting each sensor, so this is automatically adapting. All right, so that looks pretty good. We've got one last point to measure at 10, go to 10, control. And since it does take longer to take readings, if you make a bunch of adjustments in between a reading, just let it do a double read sometimes just to make sure you've got it right. Okay, that looks about as good as I can get. What we've done so far is we've gone and adjusted the gamma level at each one of these points all the way down to 10, because that's what it has, 10 through 100. A lot of things are interactive. Sometimes in the display, the controls, they're supposed to discretely adjust one point, but maybe when you adjust that point, it affects everything around it. So what you always want to do once you're done doing this, exit out of your menu system and do a complete read series all over again to see if it has impacted anything on the panel. So I'm going to remeasure all the points and see if everything is still where it needs to be. You can also notice that it looks like we've improved some of our DE levels for the DE2000 chart. And that's because DE2000, when it is calculating error, it's not calculating error just on the color balancing of each particular point. It's also including the luminance error. So it's a combination of luminance and chromaticity, which is why we use the DE2000 chart in Calman. So by changing and correcting our luminance level on the gamma curve, we also brought down the overall error in the DE2000 chart. You can also look at the color comparator, and there's practically an imperceivable difference between the RGB triplet value of what the display should look like and what the meter sees as the color. I mean, I literally cannot even see a difference between these two. So I would say this thing is spot on. Looking over here at our important numbers, we've got an average of 0.9. That's well acceptable. We've got a max of 1.5. Again, really good. Color temperature is really close to D65. Gamma 2.4. Black level 0.0235. White level, we did lose some of our peak white, so we're going to have to go ahead and bump that up in the backlight control, and we'll do that in a future step. On-off contrast ratio, we've got 3700 to 1. Let's talk about the constant APL patterns. Earlier we were measuring, in our pre-calibration phase, we were measuring our black and white. I suspect this display has the backlight control can shut off when it measures a full field black. So to prevent the backlight from shutting off completely, I'm going to go ahead and turn on the constant APL patterns. To do that, I'm going to go ahead and select the pattern drop-down tab, and I'm going to select the window size from the current one, which is the default of Windows 18, and I'm going to select constant APL 18, and I'm going to go ahead and measure 100% and measure black again. Looks like we're about the same, so it's always good to double check that. If you've got an OLED or an LCD LED, the backlight's usually shut off, so if you're getting some 3 million to 1 contrast ratio, the first thing I would do is make sure that your constant APL pattern is turned on. And then also if you see a really low black level that's 0.0000 something, your panel is probably not putting out light at its black level point. So turn the constant APL pattern on, do this measurement, and then you'll get the right data back. Now that we've gathered everything we can, the display's been calibrated for grayscale, I'm going to go ahead and click the next button. This is the color management system where you take measurements of the display's color primaries and secondaries. Not all display systems or client monitors will have controls for adjusting the primary and secondary colors. In fact, most of them don't. But if yours does, this is where you would make those adjustments. and you can see all the information that's needed in order to fix any sort of hue shift, over under saturation, or luminance where you've got too much or not enough. Even if you don't have a CMS system, in order to properly generate the report, you still want to do a read series here. So the first thing you do is click read series. It's going to gather all the data about how the display is performing for its white point, as well as the primary and secondary colors in relationship to the target Rec. 709 color space. So as of right now, I can see this display is looking pretty good out of the box. It may have a color space preset that has already been set in the mode that we're in, that's set for 709. So looking at this 1931 chart, I can see that my green measured value, and if I want to get a zoomed in shot of this green, I can select green, which will push the pattern up to the display if I want to measure it again. And then I can see here that I do have a hue shift. The measured value is this dot and the target is the square. So I may want to tweak that. Looking at blue, there's a much greater error in blue compared to the other colors. So if I was going to work on anything at all, it'd probably be this blue. So to do that, I'm going to select the blue patch. It's going to push it out to my display. I can see, yep, sure enough, I've got a hue shift. I'm also oversaturated. So I've got a hue shift, I'm oversaturated, I'm a little under in my luminance. So first thing I'm going to do is focus on the biggest problem, which is the saturation. And I'll select blue. I'm going to get my mouse hovering over the continuous read. Before I click that, I'm going to go to my menu system and find the CMS controls, if it has them. So I'm going to go Pro Settings, Color Detail Adjustment, and sure enough, looks like I have these controls. And I'm going to find blue saturation. I'm going to select blue saturation, and with that active, I'm going to go ahead and click continuous read, and I'm going to start turning it down or up to see what happens. Immediately I see the saturation come down, and I see that here saturation came way down, my error came way down, it's just over 1. Let me try one more click. Came down a little bit more. Another click, came down a little bit more. So that looks a lot better. I don't want to go too much because as you can see in my zoomed in view here, I'm starting to have a deficiency in saturation, and I'm still shifted towards the magenta secondary. So I would say that's probably good for that adjustment. And I'm going to go ahead and hit stop. As you can see, I've got 96.57 gamut coverage to the Rec. 709 color space. I don't think there's much adjustment else to make. We could take a look at green. Maybe we can try and fix some of the hue shift in green. So to do that, I've got green selected, go into my menu, find the green control, and in this case, I want to fix the hue, since I can see that the way the error in hue moves is that it moves in this kind of motion in relationship to white. So imagine a string attached to green, and if I was to move this point around, it would move in this kind of error. Saturation goes in and out away from white, so if it was oversaturated, green would be out here. If it was undersaturated, green would be in here. Luminance is the z-axis, so you can't see its error on this particular chart. That's why we have these other chartings. Got luminance error here. So with that green hue selected on the menu, I'm going to go ahead and do continuous readings, and I'm going to see if I can get that moving in the right direction. It looks like I was able to bump that over where it needs to be. I could work on this a little bit more. For this video, I'm going to say it's good enough, but if you wanted to continually tweak each one of these points, you could really dial in red, green, and blue, and by doing so, you would impact your secondaries because the secondaries are derived from the primaries. So I've got a really nice white point, I've got good primary and secondaries. I'm going to go ahead and hit stop, do a read series just to make sure that any of the changes I made didn't impact the other neighboring colors. Again, some displays, that'll happen. Displays aren't perfect, so always do a read series before you move on to the next step. Okay, so I'm really happy with this. I think this is good enough for this particular calibration. One thing I do want to show you real quickly is what happens if you're in a mode that the color space isn't this good, and that happens pretty often. So what I'm going to do is go into Picture, and just for a quick moment, I'm going to find, so in Professional, let's go ahead and just select maybe the mode that it was in from out of the box state. Let's see how close the color space is on this one. No surprise that the white point is that far off. Actually, it's not too bad, but we still see that it's oversaturated. You know, this is probably what the display's native color capabilities are. You look at the color gamut coverage, says 99%. Well, you think, well, that's a great number. However, the points are not anywhere they need to be. You know, you would want to go through, find a color space or a global preset that changes that back to closer to a 7 or 9. In this case, it's the professional one. Just going to run another series, make sure we're all good. And then we'll go ahead and move on to the next step. All right, go ahead and click Next. Okay, so we just got finished adjusting the grayscale, and then we did the CMS system, and we've talked a number of times about how the luminance is impacted by all the changes we've made. So the first thing you're going to want to do is just click a single read to see where we're at after we've done all the tweaks to this display. Now, if you remember in the beginning, I said the target is 100, and we measured it, adjusted it up to about 110, knowing that we would lose some after doing all the adjustments. Well, we lost quite a bit. We're down to 88. So all we have to do here is take continuous readings and adjust the backlight so we can bump it back up to 100 after all those changes. So I'm going to go into the menu system, find the backlight control, make sure it's out of the way, put the meter into a continuous read, and I'm going to start turning up the backlight until I'm at my target level. So the clicks are pretty rough. When I do one click, it goes from 98 to 101. I'm going to leave it at 101. I'd prefer to be slightly above than slightly under. So I think this is a good position to stop at. Now, a lot of you probably wonder, what happens if you adjust the backlight? How does that impact the calibration? Oftentimes, in most cases, the backlight has zero impact on the overall calibration. So if you go through after making the adjustment and measure grayscale again and CMS again, you'll see probably zero change. So you shouldn't worry about bumping up the backlight after you've done all the calibration work. That's why if in the beginning you can bump it up a little higher, so that way at the end it may snap into where it needs to be, then you'll be good to go. So this setting is all complete, and I'm going to click Next. Okay, so on the calibration summary page, you can see that all of the data on the left is from the pre-calibration before we started doing any adjustments in the client viewing monitor, and everything on the right is the post-calibration after we've done the calibration, adjusting the built-in controls on the client monitor. The first thing you'll notice is the RGB balance, and looking at the left chart, you'll see that we've got an overly blue, very cool color temperature for the display, and we're deficient in red, and the after shows a nicely balanced red, green, and blue white point from black to white as it ramps up. And you'll see a correlation of the DE2000 for the grayscale balance. You can see that we're way, way, way high in delta error. Or at 100, we're at 14, and it sort of scales down as it gets towards black, but still there's some significant visible error in the white point color. And you can see in the post-calibration, everything is about 1 or even under. So this should be imperceivable to the human eye in terms of the error. And then when you look at the color comparator, you can see that they almost just seamlessly blend in together. So we really nailed the grayscale, and all we did was a 2-point white balance, and we adjusted the gamma. Looking over on the pre-calibration, you can see there's a heavy blue color in the grayscale all the way up, and you see that when you're comparing it to what the RGB triplet value should be for that particular gray color. Now, looking at the CIE 1931 on the pre-calibration, you can see again the white point is very blue, and you can see that here. You can also see that our primaries and secondaries are all shifted towards blue. All of the measured points are well outside their target values. And looking at the color comparator, you can see some of those issues. In the DE2000, we have again all sorts of error above 3, and everything's all over 1. So there's some visible color shifting error here. And then when you look at the CIE 1931, the post-calibration, you can see that our white point is dialed, our primaries and secondaries are all where they need to be. Our DE2000 for the primaries and secondaries are all at 1 or under. And looking at the color comparator, there's almost barely any visible differences between these. Maybe a little bit here in the blue. It's very, very, very close. This is all within the Netflix display calibration best practices. So they would sign off on this, say client monitor is calibrated. Let's go ahead and move on to the next page. When you get to the saturation sweeps page, the first thing you want to do is just click the Read Series button to gather the data on how the display is performing. The kind of measurement points that this set of readings is going to take gives you a snapshot of how linear the display is for the color as it becomes saturated fully to its full primary or secondary color within relationship to white. If you calibrate a client viewing monitor, or any monitor for that matter, you can get the white point really dialed in, and you can calibrate the primary and secondary colors so that the edges are right. And if the display isn't processing color properly and it isn't providing linear color, you can have the inside of that color area a complete mess. So this is a great test that just shows how well the display performs at its different saturation points for each color compared to white. So far this is looking pretty good. The square boxes are the targets and the dots are the measured values. All are DE 2000 errors or around 1, so this is actually a pretty good display in terms of this test. There isn't any sort of adjustment you can do, so basically you just gather this data and then click the next button. But it's just helpful to see how, if let's say you're working on some content and maybe the material you're working on has a lot of colors in this region, well, if this display has a sort of bend in it, then your colors are going to be off. And the only way to really fix that would be to add a 3D LUT, and you could do that in a LUT box, or you could do that in software, or in some cases the monitor has the ability to load a 3D LUT directly into it. So if you see issues here and the edges are good, then you may want to consider how best to go about fixing that. All right, we can go ahead and click Next. This is the color checker page, and we have an extensive series of videos on this page, so I'm not going to go into too much detail. You can see those on our YouTube channel. It's just youtube.com/SpectraCal, and then we have a whole series called Color Checker. Basically, you just want to click the Read Series on this page, and it's going to gather a bunch of data on the display's performance. These color checker values are based on the standard color checker chart. We also have the SG expanded set of color points, as well as the new video level color checker values that X-Rite has just recently released. This is a way to see how well the display is performing in internal color space. So it's similar to the saturation sweeps, except for it's somewhat more arbitrary. If the display is a good panel and it's been calibrated, these should be relatively close to what we're seeing here, where they're around 1 or under. So far this is looking pretty good. If you ever want to go in and measure additional color patches for this set of readings, you can click the settings wheel in the top right, and you'll see down here it says color checker settings. You can click on the color checker SG set, or you can also add on additional custom patch sets. There's one for skin tones. We have obviously the Netflix logo color in here. One of our engineers decided to put in the NFL logo colors. You could make your own patch sets. So this is just a helpful way to evaluate a display's performance on color points that maybe aren't 100% of a primary or white point or grayscale. Looks like it's all done, so I'll close the panel out. You can see this is looking pretty good. So I'm going to go ahead and click the next button. This is the contrast ratio page. It's very simple. You just click the Read Series. It's going to measure 100% white, and it's going to measure black. It'll give you the measured black value, the white point value, and it's going to give you the on-off contrast ratio number, which is on the center of the screen. Nice little test to do at the very end. You've made a whole bunch of changes throughout the process, and this is kind of the last data point that you really want to know. It's just a good last check to make sure, yep, my 100 nits target value or 101, my black is acceptable and my on-off is acceptable. So we've done this now. You can go ahead and click the next button. All right, our calibration is complete. You can either click the View Report button here, which is going to save all the data throughout the workflow in the session, and if you want to access that at a later point in time, you can simply go to the drop-down and click Find Calibration Session. It will have a date stamp and time, or you can just click this button so you can generate your report for submission to Netflix. It's going to take a few seconds to render all the information, and if the information didn't populate, you can simply just click this button here that says Generate Report. It'll comb the workflow for all the data, and it'll plot it all out here within the charts and graphs. So we've got the pre-calibration, we've got the post-calibration, we've got all the color checker information, and any notes that you've typed in throughout the process will all be listed out here. This is helpful not only for yourself, but for Netflix as well. Once you're done getting all the data, you can simply click the Export to PDF, choose location and name where you want to put it, hit the Save button, and email that off to the Netflix team. Once you're done, you click the red X, and that simply jumps you back to the workflow where you last left off. If you want to start another calibration, you can go ahead and jump back to the beginning, or you can say Save Calibration Session, and it'll bring up a dialog for you to start a new one. This is a great performing display, but let's just say that your monitor doesn't perform this well. You've gone through everything you could. You calibrated the white point. You looked for CMS controls or the color management system so you could fix the primary and secondary colors, but they weren't available. They didn't exist on the monitor, and you were just really limited to what you could do with the display, and it didn't look this good. The question is, so what do? Do you buy another monitor? Is there any other sort of correction you can do? And I just want to talk a little bit about 3D LUTs. So to do that, I'm going to go ahead and add another history tab here. And I'm going to gather some more data on this display. And this is just a hypothetical. Let's say, hypothetically speaking, your monitor performs more like this. So I'm going to do a read series. It's going to gather information on my white point. And this may be a little overly exaggerated, but let's just say this is what your display is looking like after the calibration. You're feeling pretty hopeless. So what you can do here is you can add a 3D LUT somewhere in the signal path. There's 3 ways to add a 3D LUT to a display. You can add it in software that feeds the display. For example, like DaVinci Resolve software. You can add a 3D corrective LUT right inside the application, and it'll fix it through the pipeline coming out of your Blackmagic design hardware to the display. So that's one way you can do it in software. The second place you can do it is in the monitor itself. A lot of the display manufacturers have been, over the last year and a half, have been adding the ability to load a 3D LUT file directly into the display. And this is the most ideal way of fixing a monitor, is with a 3D LUT, because it's not only fixing the white point and the edges of the color space and the gamma, it's fixing all the color volume. You can think of it like the entire swimming pool of color. It's fixing all those color points, thousands and thousands of color points. So this is the most ideal way to get a good display. Another way you can do it if you don't have a monitor that has a built-in 3D LUT is you can add a 3D LUT box into the signal path. It's a simple little device. They range anywhere from $400 all the way up to $1,300. There's a whole bunch of hardware devices we support, and you basically just put the input from your source into the box, and then you have an output that goes right back out to the monitor. So it's just a directly inline device, and Calman can connect to it from the drop-down and just add the 3D LUT right into the hardware. So we've got the Blackmagic design device, we've got the Fujifilm unit, Pandora, Pluto makes one. So there's a bunch of different devices that support 3D LUTs. You can connect to it and you can generate the LUT right there, and you can correct it. So instead of having this kind of performance on your monitor, and instead of buying a new display altogether, you can add a LUT box and you can make it look more like this. That's just something I wanted to mention. I think it's important that you don't have to throw away your display. You may be able to get more life out of it. And we've seen actually quite a few of our customers where they've got some really high-end monitors that perform well on the edges and at white point, but internally in this area just don't do very well. And so they're putting these little LUT boxes on the back of the display, and they're getting a lot more life out of the monitors, so they can save on costs that way. That's all I have to say about 3D LUTs, and that's the best way to go about fixing your display if you can't fix it with its built-in controls. If you'd like to learn more about 3D LUTs, you can click this link here, which goes directly out to our YouTube channel, shows a video on how a 3D LUT can improve a client or reference monitor's color accuracy. There's also a ton of other videos there that show how to do it in software, how to do it in hardware, how to do it into a LUT box, and all the different ways in which Calman can help you through that process. Topology 2. Watch the complete series or select a chapter to jump ahead. All right, well, we just wrapped up Topology 1. This is the Topology 2 workflow, and as you can see, it's for a computer, monitor, and it's the calibration workflow, Topology 2. The goal of this workflow is to calibrate the computer monitor's built-in controls, if there are any, as well as create a 1D LUT and ICC profile for the Mac or Windows PC operating system. You can find this workflow from the drop-down once you've loaded it into the proper directory from Open Workflow Template, Netflix Computer Monitor. Here we're on the welcome screen, and the goal here is to enter all the information about the company you work for, so you can put all your data in. Your information, the phone number, email, your name. That way this can be documented in the report if somebody has a question either from Netflix or from your company, or just for record keeping. You can put all that proper information in, and it'll be stored in the report and in the workflow session. The display information, when you click New Display System, it's going to ask you about the display system name, and I typically recommend that you put the location of the room. It's Edit Bay 1, something like that. You can write up a short little description, add the display manufacturer, the model, and then uncheck this Setup Multiple Displays, and it'll give you the field for putting in the serial number of the monitor. That's just helpful for when you're calibrating the display, just to ensure that you're talking to the right profile for that particular display. And then also setting up of the standard. For North America, we've got it set up for D65 white point. It's a sRGB color space, which is the same as 709, and the sRGB gamma. If for some reason you need to change this, you can do it from these controls right here, or you can select the settings icon in the top right and then make those same changes from anywhere within the workflow. If you have questions about what standards to use, you can click this link here. It goes right to the Netflix Display Calibration Best Practices document, which is on the Netflix Backlot Help website. All right, we've covered everything on this page. Let's go ahead and move on to the next one. The Topology 2 workflow can be used to calibrate almost any number of computer monitor configurations. This workstation configuration page is intended to help you through the process. So what you want to do is select the computer location that you're going to be calibrating. With Calman, you can calibrate the machine that you're running Calman from, or you can calibrate a machine that's separate from the machine that's running Calman that's on the network. For example, if you had a room full of 100 different workstations with 2 monitors on each, you could use one laptop to move around from workstation to workstation and calibrate each of those 100 computer systems. Since we're going to be calibrating this computer, I'm going to select this computer. The operating system I'm using is Windows. If you had Mac, obviously you could select Mac, use the Client 3 for Mac, and then calibrate that way. And the display system I'm currently working on has dual Dell monitors. So I'm going to select that it's got multiple monitors. And just to kind of give you a visual cue of what the setup should look like, here you can see there's a Windows laptop. USB is connected on the meter from the machine running Calman, which is hanging over the secondary monitor that's connected to the computer system. And then I've got HDMI, DVI, or DisplayPort driving these monitors. This configuration is slightly different looking than my actual setup. I've got an actual tower computer. This will just give you an idea of how the proper setup should look like. If you're curious about some of the other setups, you can select different drop-down configurations to see how you would manage those workstations, or you can click the link here which goes to a specific video that's about calibrating this setup if you need additional help. So now that we've got that all set up, I'm going to go ahead and click the next button. After we finish the workstation configuration page, we're brought to a section that outlines how to connect all the different moving parts for calibrating this computer monitor. Depending upon the workstation configuration that you have, whether you're calibrating a computer over the network, or you're calibrating a machine that's local, or the machine that's driving Calman, or you have dual monitors or single monitors, all of those changes that you made prior to this page will slightly adjust the settings that and the instruction sets that are done here. So it's important that you have the previous page set up properly. I double checked everything, and since we know it's good to go, I'm going to go ahead and start connecting to all the different pieces. Now, regardless of the workstation configuration, you always need to connect to a meter. You can access this information here or from this tab above. I'm going to go ahead and click Connect to Meter, and since I'm using a C6 meter, I'm going to say all meters except those below. Click Search. I can see the light blinking on the instrument, so I know it's starting to talk to it. I can see that I've got a C6 activated here. It shows a serial number. The next thing that's a pretty important step is selecting the right meter mode for the display technology that I'm going to be calibrating. I already know that this is an LCD LED white. If you have any questions about what display type technology your display is, you can always feel free to reach out to our support team. You can also reach out to Netflix as we're jointly building a catalog of display make and models with the associated meter mode that you should be selecting for that particular display type. If you have any questions about this, just let us know. We can make a recommendation on what to select. But it is very critical that you have the right mode, and we can talk a little bit about that on a later step. The ICC Manager, in this case, I need to connect the ICC Manager to manage the 1D LUT and the ICC profile. Since I'm doing this all, I'm calibrating the computer monitor that I'm also running Calman from. I'm not actually connecting to a client on a remote machine. The first thing I want to do is click Client Connect and select the computer that I'm trying to connect to, which in this case is the same computer I'm running Calman from. So it's the first one on the list, and I'll go ahead and click Connect. Please note, if the Client 3 application isn't running on the computer that you're trying to connect to, you won't be able to connect to the client to manage the profile and or pattern generation. You can see here, I've got the client app running. Here are all my options. I can create new profiles, save them, add, delete. I can select the different displays I'm connected to or going to be calibrating. So it's all accessible from the tray icon, but you have to make sure that that's running first before you can connect to it. The next step of the process is selecting not only the display you're calibrating, but then the profile. If you have multiple profiles, it'll say the manufacturer Dell, the model, and I've renamed them so I know which one is which. We have number 17 is on the right, number 18 is on the left. You can do whatever you want for naming conventions. This is just what works for me. So just make sure you've selected the right display and the right profile, and then you want to make sure you open the client and do a full DDC reset. This is just going to take the display back to a nominal state if you've already calibrated it before, or just to kind of get it to a baseline. So go ahead and click that. Once it's done, you've configured the ICC Manager for this machine. And for pattern source, because I'm calibrating a monitor that I'm running Calman from, I actually don't need to connect to the client as the pattern generator. If you're calibrating a remote computer, you would need to do that here, and these instruction sets would change based on the previous page. But since I'm just going to be calibrating this machine that's running Calman, I can simply do what it says here, which is click the P button below. That's going to open up this pattern pop-up window, and then I can just drag it over to the center of the screen that I'm calibrating. And then I'm all done with this page, so I'll click Next. On the pre-calibration page, the first thing I want to do is click the Read Series button. If everything is connected and Calman is talking to all the different moving parts properly, you'll see patterns automatically start changing on the display that you're measuring, and you'll see the meter taking readings in between each of those pattern changes. While it's doing that, you'll see the data populate in real time in the charts and graphs. The first thing it does is it measures grayscale from 0 to 100 at 5% increments, and this is the PC level, so 0 to 255. You'll also notice that we've got some data that's sort of dynamically changing as it takes readings. For grayscale average, it's taking into consideration every measurement change, so it'll re-average everything each time it takes a data point. You can see here that I've got a DE average of about 4, a max 7.2, so definitely some visible error here, and actually it looks like the error is going up in our average as the monitor deviates from the standard. For color temperature, you can see we're about 1,000 over the color temperature we should be at. Since we're targeting 6503, you can see we're a little cooler than we need to be. You can see our gamma is at 2.26, our measured black level and white level we're at 260. So since this is a display system where we want to have a target of 100 nits, we'll want to turn down the backlight, or perhaps the contrast control. It really depends on the monitor to get this to our 100 nits. And then we have our on-off contrast ratio number, the points of grayscale that we selected, and then once it finishes the grayscale, you'll see it'll start taking measurements of our primaries and secondaries, and you can see the error level in those points as well. Since our white point is shifted towards blue, you can see that here as well in our CAE chart, that it's kind of pulling towards the blue primary. And there's also going to be some pretty visible error in our primary colors. Some of them are over 2, close to 3. Obviously our white is in the 7 range, so definitely visible error. Our gamma needs some help. We've got some issues in the gamma curve, and that's what the 1D LUT will work on. It will fix the RGB balance, and it will fix the gamma curve. And since it's a Windows machine, it'll load that 1D LUT into the drivers of the monitor, and then it will create an ICC profile and plop that into the operating system. Now that we've gathered all the data, we can go ahead and click Next to start the calibration process. In some cases, you will find that there isn't much you can do about this page for adjusting the dynamic range. Even if you don't think you have the ability to make any changes here, still gather the data. First thing you want to do is click the Read Series button to see if the display is clipping the signal at the top end or causing any sort of separation or color shift. And this chart is a helpful way to see that. We're looking at points of 83.5% up to 100, and we've got 6 steps. If for some reason the display was clipping or being overdriven, it would do exactly what you're seeing here. So as the monitor approaches its peak white level, it loses red and green right before it hits 100. Blue continues to go off the chart, which is okay. You really want all these lines to be parallel to one another. We can always fix bringing them close together to this target line. If the monitor is clipping, the first thing you want to do is see if you can turn down the contrast to prevent this signal from being chopped at the very top end. That's typically the control that will cause this clipping to occur. So I'm going to go into the menu system, find the contrast control, and I'm going to turn down contrast. And I'm going to do a read series to see if I can get those lines more parallel and not plateauing towards the top end. Looks like I may have helped a little bit of the problem, or actually, you know what, I think I may have solved it. Let's go ahead and, since this display actually has a brightness and contrast control, I'm going to go ahead and open up the pattern pop-up window, and we actually have a contrast pattern. It's not just a solid patch, it actually shows steps of white going up to 100%, and I'm going to click that to activate the pattern, and then I'm going to click this to push it out to the display. And while looking at the display, I can see that, yeah, sure enough, we've got some clipping here, and I can even exaggerate the problem more so if I turn it up higher. You can see I start losing, I lost box 240, I lost box 235, and I bet if I could go a little bit further, I'd start losing 230. So I want to turn this down until I can see all of the boxes going up to 254. But I don't want to turn it down so much that I sacrifice the dynamic range of the display. So it looks like 75 is about as high as I can go without losing detail. So I'm going to leave it at that, and let's do one more series read, and then we can move on to the next step. Okay, so I think that setting is good. And you know what, I'm just going to double check the brightness real quick as well, just to see if there's anything we can do about setting the brightness level. So I put the brightness pattern up, pulled the brightness control up. Now I don't know if these settings actually work properly. You would typically see the patches start blending, disappearing if we went too high or too low. I can still see all of the patterns even when it's turned all the way down. Well, maybe 4 is going away a little bit. So I'm going to keep going up until I can at least see that first step. Which it looks like it's right about there from this angle. So all done with this step, I'm going to click Next. The monitor RGB balance page is specifically about adjusting the monitor's built-in controls for red, green, and blue balance, or finding a color temperature preset that gets you close to the target. Not all displays will have this control. For example, the Apple Cinema display has 0 calibration controls, except for you can turn up or down the backlight. If you have a monitor that doesn't have RGB balance built in, you just skip this step. In this case, we actually have RGB balance controls because I've gone through the menu system and found them. So the first thing I'm going to do before I start attempting to adjust those controls is I'm going to do a read series, and it's going to gather RGB balance data at the top end and towards the bottom end of my grayscale. You can see that I've got too much blue in both the top and the 30% level of gray, and you can see that my error threshold is way off the chart. We want to target below this 1 number. So the first thing I'm going to do is click the 100 patch down below. That's going to push the 100 pattern out to the display, and I'm going to do what's called continuous read. and that's going to take measurements over and over and over again so that I can see the changes I make in the monitor in real time in the charts and graphs, and see the error come down and see the balance out. So meter's running on the right pattern. I'm going to go into the menu system, navigate down to the color settings, and I'm going to find the preset mode, go to the custom color, and now you can see I've got R, G, and B controls. Since I've got too much blue, I'm going to take blue down until it reaches about 100. Okay, and now I've got a little too much red, so I'm going to go to red, bring down red, go back to blue, and take one click out of green. So now I've got my DE under, well under 1 instead of under half a DE, and my RGB balance is really flat, and it seems pretty stable at this position. So I'm going to hit stop, click read series, and since the whole grayscale is affected by any change at the bottom or top end, everything I did here impacted the lower end here. You can see my error came down. Since this display only has one set of red, green, and blue controls, I can't individually calibrate this point and this point. I can only calibrate one set of points, which impacts both. And in this particular case, this is probably about as good as I could get with the one set of adjustments. If I went in and adjusted the red, green, and blue more, everything I do to fix this would then impact this. This is close enough. I'll let the 1D LUT do the fine-tune calibration, but this is enough to get it in the ballpark. So I'll go ahead and click the next button. On the Just Illuminance page, the first thing you want to do is click the Read Single button, and this is going to measure the 100% white to see how much light output the display is sending out. And I can see here that I've got a measured luminance of 164.43, which is much brighter than I would like it to be. So the first thing I'm going to do is put the meter into a continuous read mode. And since Netflix has suggested that you target 100 in a controlled lighting environment, and these other recommended settings depending upon different lighting conditions, since I'm in a dark room that's light controlled, I'm going to go ahead and target 100. To make this adjustment, I'm going to find the menu system for the display, see if there's a backlight control. This display may not have a backlight control. If that's the case, then you may have to try some of the other controls that may not seem like the right naming convention. Like you may have to try the brightness or the contrast control. Since the contrast control did what it was supposed to when we were measuring contrast pattern, I would leave that one alone. Perhaps this monitor's backlight control is actually called brightness. So I'm going to go ahead, go into the menu system. Since I didn't see a backlight control, I'm going to go to the brightness control. And since it didn't seem to have any impact on the black level, I'm going to go ahead and start turning this one down to see. Yep, sure enough, as I turn down the brightness, it's actually adjusting the backlight. So don't always let the names confuse you. The best way to find the display's best performing position is just to test and measure all the different options. So I'm going to keep going down. And I'm targeting 100 nits, 100 cm squared. And because the AutoCal step on the next page is going to probably take some of the blue channel out at the top end, I'm going to leave a little bit of headroom here on the luminance. That way, when it calibrates it down, it can really target down to 100 nits. So I'll leave it at about 110 and say that's good. Hit the stop button, and we'll move on to the next screen. On the 1D LUT for grayscale and gamma calibration, the first thing you want to do in the process is make sure you have the right monitor selected. And I'm just double checking that yes, I have the right one selected. Now that that's done, I can click the AutoCal button in the lower right. It looks like two spinning arrows. When I select this, it will give me the option to choose the amount of grayscale points. I'm going to actually set it to 21, and I'm going to hit OK. This process is entirely automated. It's probably my favorite part of the entire Topology 2 workflow. You can essentially walk away, go get a coffee, grab lunch, and then come back. This only takes about 3 to 5 minutes on average. If you come back and 8 minutes later it's still running, you may want to just double check that everything's been properly configured right, and or that you have the right monitor actually selected and the right profile that it's making adjustments for. So go ahead and sit back, relax, take a break, come back, and then this will be done. Looks like the calibration just wrapped up. It finished just barely over 4 minutes, and it took 61 readings. Since it's all done, I can go ahead and click OK to close out this window. And I can see that I've got a really nice DE of grayscale across the entire range. So everything's under 1. Everything's under half, it looks like, actually. So we've got an average of 0.3, and we've got a green light, says the grayscale is good to go. We've got nice balance. I'm done with this page. I can just click next. With the auto calibration complete for 1D LUT of grayscale and gamma, let's double check our luminance level to see if we need to turn it up or down to hit our target level. I'm going to click a single reading to take a measurement of 100% white. And it looks like it's still at 109, so the calibration didn't trim too much of the blue out of the signal. So I'm going to go ahead and put the meter into a continuous read. And while it's doing so, open up the menu system on the display, find the backlight, or in this case it's called the brightness control. And I'm going to turn down the brightness until I get closer to my 100 nit target. And that looks to be about as close as I can get with how granular these controls are. Now that I've set it at 100, I'll hit stop and go to the next page. Up until this point, the changes we have made have only been stored in the monitor itself for the backlight and the contrast control and the RGB balance, but the 1D LUT hasn't been applied to the computer's output yet. When we do the create ICC profile step, it will create the ICC profile that it drops into the operating system, and then it'll drop in the 1D LUT into the drivers. So that way it'll fix the output on the monitor, and then any applications on the Windows machine that are ICC aware will be remapped for the ICC profile. To start this process, I simply click the AutoCal button in the bottom right corner and simply hit the OK button. This is entirely automated, so it's going to measure our white point, our primaries and secondaries, and gamma. We'll go ahead and let this run and come back when it's complete. All right, so the ICC creation process has been complete, the profile has been made, and it's automatically been applied to the computer's operating system, along with the 1D LUT to the driver or the graphics card output. This whole process took under 2 minutes. It was 1 minute and 46 seconds and 25 readings. Now that it's complete, I'll click OK and go to the next screen. This is an important step of the Topology 2 process. It's just a step for validating that the display's color has been calibrated, not only with any built-in controls that are exposed, but also the output that drives the monitor. To start this process, you simply click the Read Series button, and it's going to gather a whole bunch of data points on the Color Checker Classic values. These are the same that are on a card that a photographer would have. It's also going to measure some grayscale steps, and it's going to give us some helpful data on DE average, max, number of points being measured, and then any of the current reading data will show up here. We have extensively covered this page in a whole video series, so if there's any questions you have about the charts and graphs, how this works, what the options are, you can go to youtube.com/SpectraCal, and you can find there's a series called Color Checker Series. I'm going to go ahead and let this run, and we'll come back in a little bit when it's complete. The Color Checker finished taking all of its measurements. Even though this display is an inexpensive computer monitor just picked up off the shelf from a regular retail store, it's actually pretty well calibrated for a lot of these color values. They're almost all under 1. I've only got a couple of them that are over 1. And so it's not a color critical monitor in this particular instance, but if it was, this is actually really, really good and would be deemed acceptable. You can also see all of the measured values. The dots are almost all in their target values. So this is good to go. I'm going to go ahead and click the next button. To see all the before and after results, you have to click the Read Series button here in the lower right, and that will gather the post-calibration information. Everything you see here on the pre-calibration information, as well as RGB balance and the CIE measured values for the white point and the primaries and secondaries, this is all gathered from the very first place we started taking measurements on the pre-calibration page. So it pulled all that data and brought it into this before and after analysis page. Now we're going to gather the post-calibration information after everything's been corrected in the monitor and then also on the output to the monitor. This step is completely automated, and I'm just going to go ahead and let it run and come back when it's complete. Okay, so the post-calibration data has been gathered. and I can do a compare contrast of all the different data points. I'm not going to go through every single one of them, but I can see right off the bat a significant improvement on the grayscale average. I went from 6.2 to 0.5. Max, I went from 8 to 1. Color temperature was at 7308, so it was cooler than it should be, and you can see that here with this blue line. Now it's 64, almost 6500. My camera is a 2.4, and looks like I improved my black level to a 0.12. White level is a target at 100 nits, and my on-off contrast ratio stayed almost the same, even though we trimmed out a lot of peak white from the 260 to 100 nits. That's because we got a significant improvement in the black level from 0.29 to 0.12. Color space average went from 4 to 0.5, and max from 7.5 to 2. So this is a nicely balanced grayscale. Gamma's fixed, and I've got my ICC profile pinpointing the red, green, and blue primaries, and also the secondaries, which snap all into line. Looks like we've done a really good calibration. I'm going to go ahead and click on the next button. The visual verification and report page shows you some visual analysis of the display's performance. Here you can see the pre-calibration grayscale. Below is the target RGB triplet value for grayscale, going from black to white. And above it is what the meter saw as the measured color. And you can see that the gamma's off because the rate of change going up from black to white doesn't match. And also there is a color shift. You can see that there is some bluish color compared to the more neutral gray. The post-calibration shows you a really nicely matching grayscale balance. The gamma is almost perfectly spot on. In fact, a lot of these I can't even see the difference between the boxes, and the chromaticity is the right grayscale point all the way up. So this is really nicely calibrated. Just kind of a neat little test. You can just visually validate how the display calibration performed. You can also look at the post-calibration color checker values to see if there's anything in here to be of concern. And once you've visually looked at all of that, you can click the Save and View Report button, and what that's going to do is going to save all the session data, and then it's going to open up the report. So click that, and then I'm going to go ahead and click Save Session View Report, and it will generate a PDF and plot all the information. If for some reason the data didn't get populated, just click this Generate Report button, and it's going to go and comb the workflow for all the data that was captured during the process. Here you'll see we have the pre-calibration information, post-calibration information, and all the color checker values. What you would do here is click Export to PDF, name it, probably your company name, the date of when you calibrated it, and who calibrated it, or maybe the monitor system. So this is something you're going to send to Netflix, so whatever naming convention they want or you want to give them, just be consistent about it. So save the PDF, email that off to them. You can click the red X here in the top right. That's just going to exit out of the reporting module and get us back to the workflow. Once I'm here, I can click the next button, and we've completed the entire calibration process. Thank you for watching SpectraCal's Netflix Monitor Calibration video series. If you have any questions, you can place them in the comment section below this video or reach out to our support team. Thanks again.